Hi, welcome to another day in the life of a commercial gas engineer. In this video, I'm going to show you what I've been up to over the last few days. So we have a boiler here, which is a Keston, and it wasn't working. Let's see why it wasn't firing up. So it was going to lock out. This gasket needed to be replaced as well. So I had a look inside to see the condition of it. It had been capped as well. Ideally, this boiler needs to be changed, needs to be overhauled, because on the water side, it looks as though it needs sorting out. This is just a look at the system that it's on. You've got 3 boilers here. And this is the valve chart. This is a look at the unit from inside. It didn't look too bad. But on the water side, there hasn't been much cleansing of the system. So there's a lot of damage around the heat exchanger on the water side. So I cleaned the burner. This is it from the other side. The fault code I got was E02. So I proceeded to check the gas valve. I wanted to see if the gas valve was opening. Isolated the gas supply. And the boiler's going through the firing sequence. And the gas pressure has dropped ever so slightly. But I'm expecting a greater rush of the pressure going right down. So I'm starting to suspect that the gas valve is the problem. The probes have been cleaned up, the ignition probes. And then it's gone to status 7 on the boiler. I seem to be getting a few gas valve problems recently. Gas valves not opening up and having low resistance values. So this is just creeping down slowly. Going through the firing sequence again before it looks as though it's going to lock out. Checking the position of the gas valve, how far it's been wound in. So now I've done the same thing to the boiler nearby, which is working without problems. Okay, so let's check the pressure now on this boiler on the right hand side, which seems to be working well. It does sound like get some strange noises from the fan on it, and let's see what happens when it goes through the firing sequence, how much the gas pressure goes down. We're just waiting for the gas valve to open up. There we go. See how much the gas valve opened? Fully. So I got my pins ready. I checked the resistance on my outer pins. And I got 53.3 ohms. So that's on my outer pins. 53.3. So from here and from here. I got 53.3 on the good gas valve. On the gas valve, which wasn't opening fully, I was only getting 51.7 ohms of resistance. The manufacturers state that I should get about 54 ohms. So on this particular Keston C55, which was installed in about 2010, it looks as though the gas valve needs to be replaced. We have an outage of hot water, total outage. So I found a pump on the plate heat exchanger that had seized. And as you can see, wasn't budging at all. Completely knackered. So there's no heat going through the clarifiers because there's no heat going through the plate to plates. Couldn't budge this one. I think it's a UPS 32 100N to 180. I was just checking the temperature in the plant room on the hot water to see what temperatures we're getting. 32. And on the plates, we're getting 62. But it wasn't quite making its way from the plates to the clarifiers. Then I started checking the amps. So I checked each phase. There's many ways of checking pumps. You can check the windings on them, but a good test as well is to check the amps. So you check the data badge, and then I'm just checking how many amps are across each of the 3 phases. So here I should be getting around 4 amps. So I'm getting 3.76 on one phase, 4.12 on another phase, and 3.7 on another phase. So I'm happy with my pump. I'm checking the temperature on my clarifier. I'm only getting 27.9 Celsius. So it's not making its way through the clarifier. And this is on one of the pipes coming out of the plates. This pipe here is the one that goes into the clarifier. It's only coming out at 19 Celsius, whereas some of the others are about 55 and another at 61. So there's heat going into the plate, but it's not quite making its way out. So we're having a circulation issue. So this pump here that needs changing is at 101 Celsius. So the heat isn't getting away from it because it's seized. I start tracing pipework, and this is another view of the plate and the circulation issues. There were about 3 plates and there were pumps that were damaged throughout. And then these are the pumps that I was checking, the primary pumps, to make sure that they were operating. And these are the values that the pump has. I was checking that valves were not seized and so on, gate valves, and tracing pipework some more. This was a tough one. Following the pipework round. We're in the process of changing the pump. Other faulty pump. Then there was one pump I was just checking the amps on to make sure that it was operating well. So here we have the different amps and the different speeds. So I've made a video on changing the speeds on these pumps. I'm not sure if you've seen that, but if you haven't, here it goes. So you can see the speed here, speed 2. And then this is the amps on speed 2. And this is how you have to turn off the power and do safe isolation. And then you can remove the cartridge and then flip it around. You disconnect it and then flip it around, as you see here. And then you get speed 1. And then here's me checking the power with speed 1, how many amps it's drawing. Checking the temperatures again in the system, they're dropping. Yes, in the end, there were more than one problem on this site. There were other pumps that were not working as well, but after changing a few of the faulty pumps, it was sorted. Here's a leak here on this pipe. And let's see how we sorted it out. And then it's a quick fix, temporary fix, tubely clip and some rubber. On this particular job, we have a lockout of EO2 on an idle IMAX W80. Good thing is we have 2 boilers nearby working, so we can use those as sort of test dummies to use parts from, or to see what's working on the others and why a similar thing isn't happening on the middle one. So we've got EO2 fault code. Let me know if you've come across these boilers in the comments below. So here is the boiler here, and we are doing a few checks. We're meant to check the flue according to that fault code in the manual. So having a look outside at the flues, making sure there's no obvious blockage. Then we're having a look to see if there's anything obvious, like the air pressure switch not being on. So this is the boiler nearby that's working. Just having a look at him, see if there are any differences, anything obvious. So I'm gonna check the temperatures beforehand on the system before I start working on this boiler. Just curious as to what they are. And we have flow of 70, return of 66. So their system seems to be operating on the 2 boilers. We're going to turn off this boiler from a few points. We're turning this off at the local isolator. Then testing our test equipment. Yes, our test equipment's working. So here we go. So you just love these gas valves where you can't get to them because they're at an angle. So loosened it up first with my socket set, and then opened up the test point. Getting my analyzer ready and purged. I realized that the system pressure was low because the pressurization unit is offline. Going to investigate this later. Wow, got a bit of a flood there. Didn't realize that the connection wasn't on properly. All the better to prevent backflow contamination. Okay, and then I topped it up to about 1 bar to 1.5 bar. And then onto the pressure test. We're going to do our typical drop test on the gas valve. It's good to zero your manometer beforehand. Zero our pressures. Gonna open our gas valve. You can also carry a tightness test before you start doing any work, before you do your drop test on the gas valve. The drop test, I mean, is to make sure that the gas valve is opening. So we got 21 millibar. So we can carry out a test to see if the gas valve's leaking first before we see if it is opening. Seems fairly stable, so we're turning on our boiler. Got more than 2 points of isolation on this, so switched off in several places. I've got my spark plug tester on it as well, and the sight glass is pretty good as well. So we've got a different fault code there, but that's because of how we've been turning off the boiler. I'm going to do step on the parameter, and then step again, and step again, and step to 4, and then turn up the set point on the boiler so that it doesn't cut, so that it cools for heat quicker. Save that. And then back to info. Show me my stages. Status of the boiler. And then here's our pressure now, 21.7. So it's attempting to light, and it was slowly letting the gas pressure away, actually fast. So there's the gas pressure. So it looks as though the gas valve's opening, but there's 2 gas valves here, and they're there so that you can get the right pressure. There's a lot of pressure that needs to get to the burner, a lot of gas. So both gas valves need to open, and what I'm going to do, just test down and test above soon. I'm going to check the probes. I'm going to look inside and inspect the heat exchanger. So anyways, here we go. You can look at the boiler that's working here. You can have a look at the ignition probes. So that's nice and lit up in the other boiler. So here's the condition of the probes that were working in the other boiler. This is the fault code. So we had EO2. We also got EO4 later, but that was because it was a non-volatile lockout. But what we were finding was EO2, so no ignition after restart. Check inlet gas pressure. We've done that. Check flue for blockage. We had a look at that. Check wiring to ignition/detection electrode. We're going to do that in a moment because I noticed that the earth wasn't on well. So I made up my own connection for it. Check condition of ignition/detection electrode. So I'm going to swap the ignition around. I cleaned it up. I also swapped it around as well. So this is the boiler that's working. Next to it, boiler number 3. Boiler number 2 is not working. So here's boiler number 2. So here's a look inside the heat exchanger. It's a bit mucky, but the flue is not blocked. On the far right, the flue is not blocked. There's still a passageway, but it does need a good service. This is the condensate trap. You can see there's water in there, and it's not blocked up. Going to empty it out and replenish the water. Okay, now I've taken out the gas valve because I changed the probes over and it still wasn't lighting. So lo and behold, I swapped over the gas valve, and then boiler number 2 in the middle started to work. So the gas valve was the problem. Although it looked as though it was opening, I don't think both gas valves were opening successfully. So boiler number 3 on my right now, I've got the other gas valve in there and it is not lighting. So I swapped them back round again, and then I got my boiler 3 back on with my gas valve on the right. So I've got 42. Got low resistance. This is a bad gas valve I found in the plant room. So you can see there, it says old on it. I found them in a box. And we're near the 40 ohms resistance. And now I'm checking the resistance on the gas valve that is not working. And I have 41, still close to 40. And then on the other gas valve on the right, I have got 41.6. So this is the gas valve that is opening, but not quite enough. Then I'm checking on the boiler on the right, boiler number 3, which was working well, and this is the gas valve back on it, and I'm getting a higher resistance, closer to 45. I'm getting 43, closer to 43 and 44, 43.5. Then I'm going to check the other one, the other gas valve, because remember there's two. So I'm getting 43, 42, 45. So combined, we have a stronger resistance on the two outer pins. Then moving on to the pressurization unit. Pressurization unit, pumps have ceased. Pump 1 and 2 have ceased. So they're going to be replaced. Thank you for joining me. Until next time, please leave comments in the section below. Bye bye bye.